Okay, now we're going to solve problem number 3, which is really problem number 4 on the set of problems. I skipped number 3 because it's quite similar. This one is a little bit different. This kind of problem, at least in part A, asks you to formulate a dynamic programming model. That means the Bellman equation without solving it, and then B asks you to solve it. So when you have to formulate, then you have to think a little bit more abstractly. So what we have here is a farmer owns K sheep. At the end of each year, a decision is made as to how many to sell or keep. The profit from selling a sheep in year N is Pn. The sheep kept in year N will double in number in year N plus 1. The farmer plans to sell out completely at the end of N years. Formulate the DP to maximize profit. So we have to identify the different parts, elements of this. So one of them is stages. And the other one is a decision. And the other one is estates. So what are the stages? Stages are the years. And they're designated as little n, from 1 to capital N. We have to make a decision every year how many to sell. So number to sell. Xn at end of year N. Year N. The state, now in order to determine how many to sell, what do I need to know? I need to know how many do I have. Sheep held, call it Sn, at end of year N, and we'll say prior to sales. Okay, now that we have this, I think we can go straight for the Bellman equation. We know that it will be of the format Fn Sn. I have this many sheep, I'll hold this many sheep in year N, and what about calculation do I need to make? Well, I'm going to try to maximize because I'm maximizing profit, and I'm going to maximize over the number that I can sell. I should note that that number cannot be greater than Sn, must be greater or equal to 0. And if I sell Xn, I'm going to make Pn Xn, that's my immediate benefit. And then I have the future benefit of N plus 1. Now, how many sheep will I have if I sell Xn? Well, I'm going to have, it's going to double. And what's going to double is what I have right now minus what I sell. Now, we could have written an expression separately for transition. I just decided to go straight for the Bellman. Of course, when n gets very high, at the end, you have to know what for the last stage. So at the end, what happens? Well, I'm told that the farmer plans to sell out completely at the end of n years. So at the end point, I'm going to make Pn Sn, and from that point, the Bellman equation is defined. This will all lead to the optimal profit, which will be which will be F1, once I go backwards all the way from N to 1, and at the beginning I will have K sheep. So this will give me the optimal profit as a result of implementing this Bellman equation. Now we're asked, of course, once we have the optimal profit, then we also have to look at how many we sell, keep track of how many we held, and do the backtracking much like we did with the previous problem. Let's take a break before we solve part B.